So very good evening, all of you guys. I hope I'm audible to you. So, uh, Abito, I think everything is fine. Shall we start the session? Okay. Yes. Hi, Ria. Good evening, Kunwar. A very good evening. So, let's continue the series, the digital network and unlock का series में questions शुरू करना चाहिए. So, कल class में हमने around 10 questions तो किया. So, let's continue that. We'll do the remaining set of questions from the yesterday's class today now. Okay. So, let's start the session. सो गाइस आपको भी पता है आज अभी तो अनअकैडमी पे ऑफर चल रहा है दैट इज 7 डे फ्री ट्रायल यू कैन स्कैन दिस क्यूआर कोड एंड ट्राई दिस एंड टुडे इज द लास्ट डे टू अवेल दिस ऑफर आज आपका लास्ट डे टू टेक दिस ऑफर गाइस यू कैन स्कैन एंड अप्लाई द कोड शंकर 10 you activate it and you will get completely 7 days free with Unacademy subscription you can watch all our classes for free okay so let's move further. So, Unacademy started distance learning program that is, you'll be getting test series and printed notes, which is for 12,600 only. You can get the 10% discount using my code Shankar10, and you can take 1 year or 2 years to 13,000 ka hai. You will get the test series and all the notebooks you will be getting for both EC and electrical. Okay, so the new batch is going to start on 18th August. So you can take the subscription and start your journey of the gate. Okay, so right, let's start the questions first. Okay, let's start with the network analysis question because you people are interested in network analysis questions more. So right, let's start with a simple question, then we'll go for a little deep. Okay, chal, let's move. So this is the question for you. First question. Right. Chalo, please try this question. Hi, hello everyone. Okay, zero point 0.6 Henry. Let us see. So you have a relay with a resistance of 300 ohms. Okay, and switch it on to a 110 volts supply. Right, and relay will be having some inductance. Fine. So if the current reaches 63.2% of its final steady state value, so you can see here the current IL formula here is 1 minus e power minus t by tau into IL of infinity. As if you know at time t equal to tau, its value equal to 1 minus e power minus 1 into final value. That is 0.632 into IL infinity. As per examiner, the time t equal to tau is given by 0.0002. Tau is equal to 0.002. That is equal to L by R. So what is your L is a R into 0.0002. So L value R तो कितना दिया 300 into 0.0002. That will give me 0.6 Henry. Very simple question. Okay. So you have a relay with the inductance and resistance. इसको कुछ सर्क्यूट में कनेक्ट किया तो इसके बाद इट डीसी वैल्यू को द स्टेडी स्टेट 63.2% it will reach. 1 minus e power minus t by tau into final value is the response. It will reach the steady state at the time t equal to tau. It will reach 63.2% of its final value. So from the tau equal to L by R concept, we obtain the value of L. So digital का एक क्वेश्चन भी नहीं किया ना, so let's do the digital questions. So try this question here. Right, give it try. And log in YouTube. I will see the possibility. Okay. Maybe at the end, if possible, I'll try for the crash course. Okay, we'll see that. I cannot assure, but I'll try. Hi, Harika. Option, right? इसके लिए इतना टाइम तो नहीं चाहिए. Okay, option A or C, let us see. Here, what is the question here? It's a combinational circuit shown in the figure. The input is a square wave. Is phase inverted in the output. इसका मतलब क्या? आपने 1 दिया तो 0 होना चाहिए, 0 दिया तो 1 होना चाहिए. ऐसा आना चाहिए यहीं पे आउटपुट में. So this to be happen when this input is 0. If your input is 0, A is given. So when the control input is 0, if you give A, you should get A bar. When will you get 0 दिया तो A bar चाहिए तो कब मिलेगा आपको? If you take a NAND gate, A into 0, 0 whole bar is 1. If you take a NOR gate, A plus 1 is A, whole bar is A bar. If you take a exclusive OR gate, A XOR with 0. So 0 and both other input is 0. You get 0. Other input is 1, you get 1. A. Okay. If you take XNOR, if the other input is 0, you get 1. Other input is 1, you get 1. In fact, this is possible with both the gates, NOR gate and also exclusive NOR gate. Okay. 1 minute, 1 minute, 1 minute, 1 minute. Oh, sorry. Examiner का question तो मैं गलत पढ़ा. Okay. See here. Examiner को ये चाहिए. It is passed on when it is 0. When you give 0, see here. If you give 0 and A, you should get A. If you give 1 and A, it should give you A bar. Okay. So it should be phase inverted when the input is 1. This is done by NAND gate. Why? Because for NAND gate 1 minute, not NAND gate also. Because 0, if you take a NAND gate, 0 into A, whole bar is 0. 0 plus A, whole bar is A bar. So ये दोनों गलत है, right? Because If you have 0, it should do the as it is. मेरे को output as it is आना चाहिए. So if you take XOR gate, 0 XOR with A. Okay, if other input is 0, you get 0. Other input is 1, 1. Then 1 XOR with A, you get A bar. Yes. So when this can be done with the help of exclusive OR gate. Okay. So understand here the input is a square wave, that is 1 and 0 only. The output when the control input is 1. So if you take a XOR gate, if one of the input is 1, if other input is 0, 1 and 0 XOR का output क्या 1. If one of the input is 1, other input is 1, 1 and 1 XOR का output क्या 0. So whatever you give here, it will be complemented. But if one of the input is 0, then other input is also 0, you get 1. मैं क्या कर रहा हूँ? So other input is 0, you get 0. Other input is 1, you get 1. You understand here? It is passing the same. So control input 0 में तो pass कर रहा है, control input 1 में invert कर रहा है. That is done with the help of exclusive OR gate. Option C is correct. Right? Very good. Right. चलो, let's move for the next question. एक एनालॉग का क्वेश्चन करते हैं. कल ये क्वेश्चन तो किया ना हमने. राइट, नाउ ट्राई दिस क्वेश्चन. Give a try. I hope you know this circuit, a stable multi-vibrator. Okay. The hysteresis of TTL inverter is used to realize an oscillator, a stable multi-vibrator or oscillator. Okay. So in the circuit, as shown in the figure, if the lower and upper trigger level voltages UTP and LTP are given by examiner as 0.9 and 1.7 in milliseconds, the time period of the output for which the output is low. He is not asking the total time period, he is asking time period में अर्धा time period, low part he is asking. How much time it is at low? That is 0. In the total time period में how much time it is at 0 he is asking. Give it a try. I hope you people can do this question. ये तो understand. Suppose initially you have the output as DC5. Okay. Then here UTP कितना दिया 1.7. Then when the 5 you have given, it will start charging and it should reach 1.7 to change its state. When input is more than 1.7, then it will go to the new state of 0. Then again, when it will start discharging, when it reaches 0.19, it should start again charging. Okay. Anybody gave answer? Shall I give a little more time? Try it यार, ये तो आसान क्वेश्चन है, तो ज़्यादा डिफिकल्ट भी नहीं. If you know the concept, you can answer it. Analog पे basics, if you know, that is sufficient. Good. Try it यार, थोड़ा सा टाइम एक्स्ट्रा भी ले रहा हूँ मैंने. It's not a difficult question at all. It is same as the previous question which we have done yesterday's class. ये तो similar question है. Last 10 seconds. 0.217 milliseconds. Let us see, Kunwa. Okay, let me try. So I'll explain the concept here. Please understand carefully, guys. So your output here, the oscillator will be generating the output of like this. It will generate 5 volts. So it will generate an output of 5 volts and 0. 5 volts and 0. So this is what you will be getting at the output. So when this value is 5, the capacitor charges. It will reach to the value of maximum how much? 1.7. Okay. So when it becomes 0, then this 1.7 will discharge up to how much it will discharge according to the question? 0.9. Okay. So this value, just a minute. So again, when it is 1, it will charge. This is what happens. When the capacitor is charging beyond 1.7, immediately the output will change its state and it starts discharging. When it discharge होके 0.9 से कम होने के लिए try किया तो immediately इसका output change हो जाएगा. So how it will changes? Normally theory class में we will be discussing like this. For example, इस case में by voltage division principle, suppose यहीं पे 10 है तो यहीं पे 5 आएगा. When capacitor चार्ज होने समय पे यहीं पे 5 से ज्यादा आएंगे तो क्या होता है सर? कंपैरेटर विल गिव यू चेंज द आउटपुट टू -10. देन -10 -5 आएगा. फिर -10 पे डिस्चार्ज होके -5 से कम हुआ तो again it will change its state. This is how it will generate the waveform. Okay, so now listen here. So this is how your voltage across the capacitor is varying. Now according to examiner question, he want to know this time period. Okay, say this is 0 and this is some t1. Okay, assume this as 0 to make my analysis easy. So now firstly listen here. What is the voltage across the capacitor during this period? ये वाला time पे. Okay, during discharge वाला समय पे voltage across the capacitor कितना? Initial voltage 1.7, right? So what is the formula? Is Vc of infinity. At infinity, when it is discharging, a discharge समय पे, okay, because here the output is at low, he is asking. When it is discharging, okay, here you will get 0. So ideally at infinity it should go to 0, but because of this internal action it might be changing. So final value plus initial value 1.7 minus final value e power minus t by tau. Okay, this is the capacitor voltage in the RC circuit. So it is discharging with a value of 1.2 e power minus t by tau. Okay, so now at time t equal to t1, t इक्वल टू t1 में मेरा कैपेसिटर कितना वोल्टेज तक आ रहा है? 0.9 पर. So Vc is equal to 0.9. So you need to find that time. That is the question. So 0.9 is equal to 1.7 e power minus t by tau. So e power minus t by tau equal to 0.9 by 1.7. हो गया क्वेश्चन. ठीक है, इतना आसान है. So minus t by tau equal to ln of 0.9 upon 1.7. So what is your at time t equal to capital T1. So T1 कितना होता है सर? Minus tau ln of 0.9 by 1.7, or you can say tau ln of 1.7 by 1. Right? So tau कितना है भाई? Tau is equal to RC 10k into 10 power minus 5. 10 power 3 into 10 power minus 5 is 10 power minus 2. Sorry, 10 power 4 into 10 power minus 7. 10 power minus 3. Can you do the calculation? मेरे पास कैलकुलेटर है क्या? ये कैलकुलेटर है. How much? ln of 1.7 by 0.9. 0.635. Okay, 0.63. Very good, yeah. Convert, right answer. 0.63 milliseconds. That's right answer. This is a, I mean, little more frequently occurred model here, multi-vibrators wala concept. So please learn this concept properly. प्लस पे मैं तो ये कॉन्सेप्ट जीरो से कंप्लीट किया. If you want anyway, presently plus is free for you for 1 week. You can go through it. Yes, right. Any doubt? Anybody? Yes, na. When it is at high, it is at 5 volts, na. If it is 5, output is high. So capacitor charges to 1.9. Then immediately it will change its state to 0. Then what happens? It will discharge. When output is 0, it will discharge. When output is at high, it will charge. Right? चलो, let's move for the next question. So next question तो networks का चाहिए ना. So let's try this question, yeah. This question is a little mix of some microprocessor and something also. It's a good logical question. Let me check how many of you are able to do this question. एक मिनट तो कम है इस क्वेश्चन. I'll give you hints, okay, and you people parallelly try the question. So let me read and explain you the question. You have a microprocessor controlled measurement system. Okay, to Rx is the unknown. ये वाला resistance आप calculate करना चाहिए. Okay, it is to be measured while you know the value of R reference and C reference are known. Many people don't like to read the question itself, but read it. Then only you can be able to do it. Now, please listen. C reference is charged. This capacitor is charged from which voltage? VL जैसा voltage to VH by a constant DC voltage source VS. VS वाला voltage connect करके ये R and C वाला circuit तो charge किया कहाँ से कहाँ तक VL से VH तक. ठीक है. ओके, वंस थ्रू एक बार कैसा किया आर रेफरेंस. ओके, जैसा विथ आर रेफरेंस एंड सी रेफरेंस से यूज किया. इट रिक्वायर कितना टाइम लगा है इस समय इसके लिए टी रेफरेंस टाइम लगाया. देन इसको डिस्चार्ज किया टू वीएल. वीएच पे है ना, वो वीएच से वीएल तक डिस्चार्ज किया. देन अगेन सो मेरा इनिशियल वीएल से वीएच तक चार्ज किया यूजिंग आर रेफरेंस एंड सी रेफरेंस बाय कनेक्टिंग टू वीएस. इसके बाद क्या किया? देन अगेन इट इज डिस्चार्ज टू वीएल एंड फिर चार्ज किया फ्रॉम वीएल टू वीएच थ्रू नाउ आरएक्स. इसलिए इसमें कितना टाइम लगाया? टीएक्स. So if you know that Tx is equal to K times T reference, then what is the value of the resistance? Question is easy. Yes or no? In a nutshell, I can explain again for you. See here, मेरा पास एक सर्क्यूट है. इस सर्क्यूट में आर रेफरेंस सी रेफरेंस वाला सर्क्यूट कनेक्ट करके इसको डिस्कनेक्ट करके एक बार मैं कैपेसिटर को चार्ज किया VL टू VH. इसमें कितना टाइम लगाया? T कितना टाइम लगाया? T रेफरेंस समय लगाया. Then again I discharge this to VL and again charge it to VH using RX and C reference. उस समय पे कितना टाइम लगाया? TX. By using this information, can you find the value of Rx? Okay, so try this question here. It is not difficult. ऐसा नहीं, कोई difficult questions तो नहीं होता है भाई. Complex solutions हो सकते हैं. Okay, the way if you think, you make the analysis easy, you definitely able to solve this question. It is not at all difficult. Please think in that way. You will be able to solve it, no doubt in it. Please try. Okay. आपको पता है कैपेसिटर का फॉर्मूला फाइनल प्लस इनिशियल माइनस फाइनल ई पावर माइनस टी बाई टाउ. ठीक है. When VS is connected as the supply, फाइनल वैल्यू इज Vs होना चाहिए. Okay, but at time t equal to t reference, it has been equated to Vh. Okay, with initial value of VL. Use these concepts and find the value of Rx. No response. सोच लो यार, तो almost explain किया question को. You will be able to solve it. I feel that. Okay. So think. Cosmos, तुम मेरे क्लास में पहले किया क्या? स्माइली से दे रहे हैं आंसर. Okay, don't test your luck. Okay, if you have done, it's good. Let me explain the things. Okay. So firstly, okay, here initially, first case में VL to VX, VH, VL से VH हो रहा है through R reference into comma C reference. Okay, it is getting charged through R reference and C reference. Okay, and supply it now VS. Now listen here. Okay, what is the capacitor formula, voltage formula? VC equal to final value is Vs. If you don't, if final का मतलब if you don't disturb the network up to infinity, इसका final value तो नहीं है, plus initial minus final e power minus t by tau. Tau is equal to how much here? R reference into C reference. Okay. Say I can say tau 1. What is tau 1? R reference into C reference. Okay. Now listen here. At time t equal to t reference, my VC is equal to VH. It is Vs plus VL minus Vs e power minus t by, sorry, t reference. Tau 1. Okay, leave it. Now the second time what they have done, सेकेंड टाइम पे सेम स्टोरी रिपीट किया, VL तक डिस्चार्ज करके फिर वापस VL से VH चार्ज किया, VL से VH तो चार्ज किया. नाउ थ्रू कौन सा कैपेसिटर? थ्रू माय RX एंड एक मिनट, RX एंड C रेफरेंस कितना टाइम लगाया? TX टाइम लगाया. RX and C reference. Okay, same supply. Then now tau 2 equal to RX into C reference. In time TX as per examiner. Okay, so now same story. VC equal to final value plus initial minus final e power minus TX by, I'm sorry, T by tau 2. Okay, now same at time t equal to Tx, your VC equal to VH. Okay, it is equal to Vs plus same story, VL minus vs e power minus tx by tau. ओके, ये दोनों सेम है ना, वी एक्स वी एच, इक्वेशन 1 और 2 ये दोनों इक्वेट करो. ओके, सो फ्रॉम फर्स्ट वाला इक्वेशन एंड सेकंड वाला इक्वेशन अगर दोनों इक्वेट किया तो वी एच इक्वल टू वी एच, सो वी एस कैंसिल्स, वी एल बाय माइनस वी एस कैंसिल्स, देन व्हाट डू यू गेट, ई पावर माइनस t reference by tau 1 is equal to e power minus tau x by, sorry, tx by tau 2. ओके, बट एग्जामिनर तो क्या दिया, tx is equal to k times t reference, given tx is equal to k times t reference. हियर एक्सपोनेंशियल एक्सपोनेंशियल दोनों साइड लॉगरिथम अप्लाई करके कैंसिल कर सकते हैं, माइनस भी चलेगा. सो टी रेफरेंस बाय tau 1 is equal to tx कितना दिया एग्जामिनर, k टाइम्स t रेफरेंस by tau 2. ठीक है, then t reference cancels, then what is your tau 2, it is equal to k times tau 1. What is tau 2, r into c reference. What is the tau 1, r reference into c reference. Then what is your unknown distance are, k times r reference. Okay, just a moment. Yeah, rx. So rx. So what is the rx value is nothing but k times r reference. So अगर solve किया तो it is not at all difficult, you feel, right? How many of you are able to solve it? Let me check. ऑप्शन बी तो नहीं भाई, ऑप्शन सी. आपने गेस किया क्या? ठीक है, बी सुंदर दिख रहा है. I hope you understand the solution. Very good to see. Fine. Shall we move for the next question? Is it clear, guys? मैंने आपका एनर्जी चाहिए, एक बार कमेंट करो. Is it clear or not? Okay, shall we move for the next question or not? Yes, चलो, let's move for the next question. एक डिजिटल का क्वेश्चन करके वापस जाएगा. ओके, एक आसान क्वेश्चन सेलेक्ट कर रहा हूँ. ठीक है, चलो, ट्राई दिस क्वेश्चन. So try this question. ऑप्शन डी। चलो, इस क्वेश्चन को आसान से करने के लिए बेस्ट तरीका क्या होता है सर? के मैप। ठीक है, बिकॉज यू नो द कॉन्सेप्ट ऑड नंबर ऑफ वंस में आउटपुट इज इक्वल टू वन. So take a simple K map. It makes your analysis as easy as possible. ठीक है, so यहीं पे ये भी और सी भी, when you have odd number of ones, output is one, and it will also satisfy diagonal adjacency as we know that in our digital class में तो बताया. ठीक है, और your input contains 0001 एक ही वन, 0010 एक ही वन, 0100 एक ही वन, 0111 तीन वंस, odd number of ones पे वन होना चाहिए. So if you take this 0 1 3 2 4 5 6, sorry, 4 5 7 6 8 9 11, sorry 12 11 13 14 15, अरे यार क्या कर रहे हैं, 12 13 14 15, right? Okay, 8 9 10 11. So it is sum of the mean terms 1 2 4 7 8 11 13 14, and product of max terms 0 3 5 6 9 10 12 15. 0 3 5 6 9 10 12 15 is the product of the max terms, and sum of the mean terms 1 2 4 8. So 1 and 3. Option D is the right answer. Good, good, good. Sahu, Kunwar, and Gaming Japan, right answers. Now let's move for again another question. एक minute. Just 1 minute. I'm sorry. फिर इसको कॉपी करना चाहिए मैंने. Okay. ठीक है, समझ में. Try this question, yeah. Okay, try this question. This is from the filters concept. Give it a try. So, any other answers? Okay, last 5 seconds. Oh, very good. Saku, Kunwar, what is your name? Chappanu, Srivatswa. Very good, very good. So this question options देखेंगे तो थोड़ा सा complex दिख रहा है, but firstly think, listen here. It is a voltage follower circuit. Yes or no? RF में कोई फायदा नहीं क्योंकि RF से कोई करंट तो नहीं चलेगा ऑप एम्प का आइडियल ठीक है ये करंट तो जीरो ठीक है so this resistor is not having any sense so whatever you have this Vx here your V naught is equal to Vx by virtual short concept. So what is your Vx? Vx is equal to Vi into 1 by Sc by R plus 1 by Sc. So Vi by 1 plus SCR is your V naught. So what is V naught by Vi? 1 by 1 plus SCR. ठीक है 1 by 1 plus SCR. Right. Now examiner का required क्या? V naught by V 20 log here, if you see all the figures, first thing you should understand what is the cutoff frequency? Omega C. Omega C equal to low pass filter में 1 by RC. RC value कितना here? 1 by 10 power 3 into 10 power minus 6. 1000. Next, H of J omega equal to 1 by 1 plus J omega RC. 1 by 1 plus J 2 pi FRC. 1 by 1 plus J F upon FC. This is your H of J omega or JF. ठीक है अभी ध्यान से देखो इस केस में जनरल लो पास फिल्टर का एनालिसिस व्हाट इज द एंगल ऑफ H of J omega माइनस tan इनवर्स ऑफ F by FC ठीक है so at F equal to FC it will be equal to minus 45 at F equal to infinity it will reach minus 90 at F equal to 0 the phase angle is equal to 0 ये तो हमेशा नेगेटिव होना चाहिए with respect to F ये phase angle तो ऐसा चेंज हो रहा है phase का प्लॉट magnitude का प्लॉट you can see it is decaying at a rate of 20 dB per decade. Okay, if you apply 20 log this one, the magnitude is decaying at a rate of 20 dB per decade. Or you can say minus 3 dB per octave also. If you study control systems, you might be knowing that concept basic. Okay, now come here. So at what frequency you have the cutoff frequency? 1000. So here you see. Originally speaking, it is not a original straight line, but thoda sa niche hona chahiye, but still fine. 1000 pe you have this change here. Okay, and here you have a change at 100. So definitely this is not your answer. This is not your answer. Gain is not at all increasing. Gain तो fall हो रहा है. ठीक है. So your answer must be either B or C. B or A. Definitely C D तो नहीं है. B or A. So ये दोनों में magnitude for plot तो same दिया. So phase plot देखो. Phase plot according to us at omega equal to omega c its value is minus 45, at infinity it is minus 90 and it starts from 0. ये perfectly correct है. ये यहीं पे देखो it is positive angle से minus plus 45 से minus 45 जा रहा है इसका phase plot. But according to us हमारा analysis में आपको क्या मिला? It is varying from 0 degrees to minus 90 degrees. So which option is satisfying our condition is option A. केवल ऑप्शन ये सही है. ठीक है. Right. Perfect. Okay, chalo, let's move for the next question. Let's solve one question of network analysis first. ठीक है, एक आसान क्वेश्चन सॉल्व करते हैं. अभी तक थोड़ा सा कॉम्प्लेक्स क्वेश्चंस किया ना. इसके लिए 1 मिनट भी नहीं चाहिए, बट ले लो. Try this question. It's a very simple basic question. I hope you people can do it. Not at all difficult. But this r plus jx, r minus jx, thoda sa most frequently occurred in many examinations. That's why I have collected and kept this question. अरे यार इतना टाइम क्यों ले रहा है? बहुत आसान क्वेश्चन है. इट इज ए डूएबल क्वेश्चन. आप तो दिक्कत वाले क्वेश्चन ही आसान से किया. फाइन, हो गया. ठीक है. सो द क्वेश्चन हियर इज द टोटल, बहुत बेसिक क्वेश्चन. फाइंड द इम्पिडेंस. I want to give you one concept so that it will help you later also. If you take here R, JX, R minus JX, ये तो हमेशा रेजोनेंस में होता है ये वाला ब्लॉक, and the total impedance will be purely resistive whenever you have R plus JX and R minus JX in the combination. Okay, this circuit will be at resonance for all the omega. ठीक है. So now see here, r square equal to L by C वाला condition भी satisfy हो जाएगा यहीं पे. Now see here, okay, see r minus jx parallel by r plus jx. Okay, r minus jx into r plus jx by r minus jx, r1 r2 by z1 z2 by z1 plus z2. So a square plus b square minus jx plus jx cancels 2z. Okay, this is the a block का equivalent. So simply इस question पे r square कितना, 3 square plus 4 square by 2 3s, that is 9 plus 8 15 by 6. So total z equivalent कितना होता है सर? 17 by 6 plus 15 by 6. ठीक है. 15 22 32 क्या हुआ ऑप्शंस में? नहीं, 42 होना चाहिए. 9 plus 16 25 ना. 42 by 6 7. So 7 plus 8. So whenever r minus jx, r plus jx comes, don't calculate, simply r square plus x square by 2r add करो. The reactive part will be nullified and it will be purely resistive only. Okay, approximate 9, perfectly what we call perfect answer. Accurate answer. Okay. Chalo. Let's move further. Next question पर. एक डिजिटल का क्वेश्चन करते हैं. Yeah. Please try this question. जूम किया. ओके. थोड़ा सा पेशेंस चाहिए पढ़ने के लिए. क्या हुआ यार? If you read the question, you can answer it. It is not a really difficult question. ये तो दिक्कत वाला क्वेश्चन तो नहीं है. Good. Directly proportional to V reference. Perfect. Circuit shown in the figure, counter-based unipolar ADC. When SOC is accepted and start of the conversion signal is given and the clock is enabled, the counter counts and the DAC output grows. Simply the clock is given, counter will be counting. Accordingly, the DAC will be giving the output. It will compare the input and DAC. Okay. So the comparator switches to logic 0. Uh, when the DAC exceeds the input, actually, ये होना चाहिए. Okay. When DAC का output is exceeding the input signal, then what happens? When DAC का output is more than the input, then the comparator will give you 0, and then the control logic will stop the counting by disabling the clock. Okay. Comparator switches to from logic. Okay. It's correct. I'm sorry. It's a different. Okay. Whenever this value increases than this negative value, then it will become 1 here. That 1 will change this control logic, will convert the clock inside. Maybe you have some sort of like this. Okay, here you have clock. Here you have some comparator output x. When x equal to 0, you get the clock bar. Okay, when x is equal to 1, what happens? 1 into 1. 1 minute. You have this. Okay. Clock and x. Okay, when x is 0, you get clock. When x is 1, 1 inverse is 0. 0 into anything is 0. Clock will be disabled. Some sort of circuit is there, leave it. Okay, this kind of. Okay, fine. So, and it will make the end of the conversion is done. So, it is nothing but simply a counter type ADC. Okay, assuming the components ideal, V reference, DAD output, input, everything is positive. The maximum error of the conversion इस केस में ज्यादा से ज्यादा कितना एरर होता है? इट इज इक्वल टू वन स्टेप साइज ऑफ द डीएसी. Yes or no? Because suppose if it is at 6.5, it is growing 0.5. Okay, say 6.6. Okay, 1.5. It will go to 6.5 and stop at 7. Originally it is 6.7. It stop at 7 because the error here is 6.6. So suppose if it is 6.51, error is 0.49. Like that, maximum ज़्यादा से ज़्यादा error will be equal to 0.5, which is equal to step size. Step size is nothing but resolution, which is given by the formula. This is V reference by 2 power n minus 1. So he is asking the conversion pay error is proportional to V reference. Yes, error is nothing but resolution, which is proportional to V reference. Okay, it is just a counter type ADC. He has given more explanation. That's all. Right? So remaining all options are no. चलो let's move. So I think time up. ठीक है, फिर बंद करते हैं आज के लिए. ठीक है, चाहिए तो एक क्वेश्चन, लास्ट क्वेश्चन करना क्या? इस क्वेश्चन तो कल करते यार, आज आप लोग होमवर्क ले लो. एनमॉस सर्क्यूट एंड फ्लिप फ्लॉप वाला सर्क्यूट. ठीक है, कल करते हैं वाला क्लास क्वेश्चन. ये तो कल किया ना मैंने ऑलरेडी. हाँ, बस ठीक है, फिर बंद करते. एक आसान क्वेश्चन करके बंद करना क्या? ये तो बहुत आसान क्वेश्चन है, छोड़ दो. ठीक है, we will meet tomorrow again with some new set of questions. Okay, so anytime you want to take an academy का subscription लेना चाहिए तो हमेशा you can feel free to use my code Shankar10 to get the maximum possible discount at that particular time. ठीक है, so these are the current prices of different months you have, and right now there is a great offer going on, guys. So if you want to learn analog from me, no need to wait for my YouTube initiative. Yeah, you can directly come to Plus now free. Okay, you just watch all my classes which are available right now. मैं तो 2 चैप्टर कंप्लीट किया अभी तक, डायोड्स एंड दिस वन ऑफ एम्प. ये पूरा यू कैन स्टडी फॉर फ्री. जस्ट स्कैन दिस QR कोड, register with your new number and activate the code Shankar10 and start your learning. Okay, thank you very much, guys. Love you all. Tomorrow also we have the session at 9 p.m. We'll meet again. Okay, thank you. See you. Good night.